Starting Unit C, we are going to do several things that you haven't done before. What we're going to do in Unit 7C is we're going to do these things called proofs, and we're going to do these things called the graphs of sine, cosine, secant, and cosecant. So I was not the person who wrote your worksheets, and I like certain things about your worksheet. There's certain things I don't like about the worksheet. So I had to do your notes in a slightly different way this unit because the unit, somebody else made it, and my mind is not super happy with how certain things are laid out. Okay? So these notes are for you to be able to do worksheet 1, the whole thing, 1 through 5. And worksheet 2, 1 through 5, which is half of it. You're going to be able to, hopefully, complete worksheet 1, 1 through 5, and answer the first 5 questions on worksheet 2. After we're done with these notes, I'm going to literally give you about 60 minutes for you to start and do this first assignment. As you do that first assignment, you are going to answer several questions that look similar to what this looks like right here. And you may not know what you're doing just yet, but hopefully by the time we're done going over these notes, you'll go, oh, I know exactly what we're doing. And let me give you a hint. Oh, that's not going to work, huh? I want to click on this link. Maybe if I use this. Oh, yeah. There we go. Here we go. There's a graphic that I had a link saved to. This is what you're going to be doing. You're going to be taking values from the unit circle. Unit 7B was dealing with the unit circle. And the unit circle had a sine on it, it had a cosine on it, it had a tangent on it, and you were even able to find secant, cosecant, and cotangent, right? This graphic is only for the sine. It's only for the y value. How far is the y value from the x-axis? That's what this graphic is showing you. As you go around the unit circle, let me say some key points. 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, or 2 pi radians. There's a certain value or a certain distance away from the x-axis you are. So if we were to go around and pick some points around the unit circle, we should get a graph that looks something like this graphic. This graph that you see here is called the sine wave. Wave. I'm just kidding. But it is called the sine wave because when you unravel the unit circle, certain values will give you a nice smooth curve that has a lot of ups and downs in it. Some people call the sine wave life, because life has lots of up and downs, and you just have to, if you're in a low point, don't worry, stick around. There's going to be a mountain behind every valley or something like that. Okay? So with that being said, this is what we are going to do. We are going to graph the sine function by plotting each angle as an input and each ratio as an output. And we're going to be turning ratios into decimals, rounding to the nearest tenth. For example, root 2 over 2 will be about 0.7. And we're going to use some things. Your worksheet's going to ask you to use highest value, and I'm going to use the word maximum value. I've been teaching it for the last 7 years with maximum and not highest, so I want you to know those words are interchangeable. The lowest value is what your worksheet uses. I've been using minimum for the last 7 years, so I want you to know that I will use those interchangeably. Predominantly, the ones on the right are what I will use because I've been teaching it that way in AMA for the last 7 years. Your worksheet says things like location, and I don't like that terminology. I like the word inputs instead. So when you see the word location, I want you to know that means your inputs, what you're plugging in. And so with that being said, this is what your worksheet 1 looks like. You will have a table. This table is only the first 3 sets of boxes that you're going to have. You will actually have 16 boxes to fill in. And I'm going to do 3 of them with you. They're very fast. They're very easy to do. What this is saying is, if you have the sine of 0 radians, what is the sine of 0 radians? You might have to actually remember what goes on in your unit circle. So if I'm thinking of your unit circle, 0 radians, the sine is the y value. What's the sine of 0 radians? Tell the person you're sitting next to if you remember.
0.
Good. As a decimal, guess what that is? 0. Piece of cake. Now, if you were to do pi over 6, that's its first value, and if I were to write the ordered pair, it would be root 3 over 2 and 1 over 2. What is the sine of pi over 6 as a fraction? What is it as a decimal? The good thing is a lot of you remember your unit circle from 7b. The 7b unit circle does not go away. You might be using your hand trick a lot today, possibly. And so the last one we have pi over 4. Paramu? Sure. Sure. Yeah, send it. Bye. So pi over 4, the sine of pi over 4 is... Now, as a decimal, if I look that up in the calculator, it's 0.707. I'm going to round that to the nearest tenth. I'm going to write that down as 0.7. So you're going to make all these values, and you're going to have stuff that goes up to a positive. And when you get to the other side of the unit circle in quadrant 3, you're going to have some negative values, the negative decimals. And then what you're going to do is you're going to plot those points. So if I have the sine of 0 radians, and that's my x, my y value is 0, I would put a dot on 0, 0. 0 for my x, 0 for my y. For pi over 6, I should be at a value of 0.5. So I go over to pi over 6, and I put a dot that is 0.5 units away above the pi over 6. I'm graphing them as ordered pairs. I'm putting dots. Then I put pi over 4 is about 0.7. So I'm going to go up and I'm going to estimate 0.7. 0.75 is halfway, so I'm going to go just a little bit less than halfway. And I'm going to put my dot, if it will let me. Right about there. And as you do this, you're going to get several dots, and I'm hoping that you're going to start to see something that looks like that graphic I showed you earlier. Does that make sense? That's what we're going to do. Yabi.
So how do you know where the pi over 6 and pi over 4 are on the x-axis?
On what?
On the x-axis.
It will be on the graph paper. See how it is here on the graph paper? It's going to be given to you on the one that you have to do on your worksheet.
So you don't have to know like why or how to find it?
Nope. Nah, I'll go through that with you if you need to know how it's there, but it's just fractions. But all. Okay, so I'm going to stop your notes right there.